Hello everyone, today we will talk about the chemical equation and chemical reactions, and this is for Prep 1, Unit 1, Lesson 3. From the previous studies and the previous lessons, we have known that the compound is a substance formed when the combination of atoms of different elements due to the chemical reaction between them. And today we will talk about the chemical reaction. What is the meaning of chemical reaction? Before we start, we have to know that the chemical reactions are everywhere around us, in cooking, in respiration, in hair dye, in auto fuel. The chemical reaction, it's a process that involves breaking the existing bonds in the reactant molecules and forms new bonds in the products. So, for making a chemical reaction or to make a chemical reaction, we have reactants and we have products. And to express the chemical reaction and express what happens during the chemical reaction, we express it in a simple way called chemical equation. What is the meaning of chemical equation? It's a set of symbols and chemical formula representing the reactants and the product molecules in the chemical reaction. And it also represents the conditions of the reaction if they exist. In chemical equations, we have reactants. And what are the reactants? They are the substances that exist before a chemical change or reaction takes place. What are the products? The new substances that are formed during the chemical changes. And the chemical equation indicates the reactants and the products of the reaction. The chemical equation must be balanced. What is the meaning of balanced? It must have the same number of atoms of the same kind on both sides. So, in balanced chemical equation, I have here, it's an equation in which the number of atoms entering the reaction equals the number of atoms results from this reaction. For example, here, I have a comparison between unbalanced and balanced chemical equation. Here, in unbalanced chemical equation, I have here two hydrogen atoms or a molecule of hydrogen and a molecule of chlorine which contains two atoms of chlorine and it produces a molecule of HCl or hydrochloric acid. So I have here two atoms of hydrogen and produces one atom of hydrogen, two atoms of chlorine and produces only one atom of chlorine, and this is totally wrong. To balance the chemical equation, I have here reactants and I have here products. In the reactants, I have here two hydrogen atoms, and chlorine, I have two chlorine atoms. In the product, I have only one hydrogen atom and one chlorine atom, and this is unbalanced equation. To make a balanced chemical equation or to make this equation balanced, I should have here two hydrogen atoms entering the reactions and two chlorine atoms entering the reaction, and I have here two hydrogen atoms results from the reaction and two chlorine atoms results from the reaction. So this is a balanced chemical equation. So here I have a comparison and example for unbalanced and balanced chemical equation. In the unbalanced chemical equation, the number of atoms of the reactants doesn't equal the number of atoms in the products. While in the balanced chemical reaction, the number of the atoms of the reactants equal the number of atoms in the products. For example, here I have here the reaction between magnesium and oxygen. Here I have the number of atoms of magnesium, two atoms of magnesium and two atoms of oxygen. Produces two atoms of magnesium and two atoms of oxygen. And here we multiply 2 in magnesium and 2 for oxygen. So I have here 2 atoms of magnesium produces 2 atoms of magnesium and 2 atoms of oxygen produces 2 atoms of oxygen. But the difference here that I have here 2 molecules of magnesium and 2 atoms of oxygen. magnesium element, oxygen element. By the effect of heat or by the effect of burning, it produces 2 molecules of magnesium oxide, and this is a compound, while these two are simple elements. So here I have the chemical equation: 2 atoms or 2 molecules of magnesium with 2 atoms of oxygen produces 2 molecules of magnesium oxide. In the second example here, I have carbon element and oxygen element. 1 atom of carbon and 2 atoms of oxygen. By the effect of heat also, it produces carbon dioxide. 1 atom of carbon produces 1 atom of carbon. 2 atoms of oxygen produces 2 atoms of oxygen. So here this equation is balanced because the number of atoms that enter the reaction equal the number of atoms that results from the reaction. Here another drawing for the same example, that carbon, 1 atom of carbon and 2 atoms of oxygen produces carbon dioxide. 1 carbon atom in the reactants and 1 carbon atom in the product, 2 oxygen atoms in the reactants and 2 oxygen atoms in the product. So this equation is balanced. Here in this reaction, it's the opposite of the balanced equation. It's an imbalanced or unbalanced equation. Why? Because here I have 2 hydrogen atoms, H2, and 2 oxygen atoms, O2. In the reactants here, I have 2 hydrogen atoms and 2 oxygen atoms. So what are the products? I have the product here, H2O, a molecule of water, which contain 2 hydrogen atoms and 1 oxygen atom. And this is definitely wrong, because the number of reactants, the number of atoms that enter the reaction, or the number of atoms that the reactants must equal the number of atoms of the products. So here 2 hydrogen atoms, 2 hydrogen atoms, no problem at all. But 2 oxygen atoms produces 1 oxygen atom. This is definitely wrong. So this mistake must be repaired. How can the unbalanced equation be balanced? By adding 2 before H2O and by adding 2 before the hydrogen. So I have here 2 or 4 atoms of hydrogen entering the reaction, and 4 atoms of hydrogen leaves and produced from the reaction, and I have here 1 oxygen molecule or 2 oxygen atoms and produces 2 oxygen atoms. So this equation now is balanced. To balance the chemical equation in an easier way, let's see how can we balance a chemical equation. Let's see here. I have magnesium element plus oxygen element produces magnesium oxide, which is compound. I have 1 atom of magnesium, 2 atoms of oxygen produces magnesium oxide. To balance the chemical equation, you have to list the atoms that are involved on each side of the arrow. For example, here I have the atoms that are involved in the chemical reaction. I have magnesium and oxygen. And here magnesium also and oxygen. To balance the chemical equation, here you have to list the atoms that you are involved on each side of the arrow. Like here, I have magnesium and oxygen, they are the reactants. And here, magnesium and oxygen, which are the products. Then we start balancing. Count the atoms on each side. Here, on the side of the reactants, I have 1 magnesium atom. And then the side of the product, I have 1 magnesium atom. So there is no problem in the magnesium. Let's see in the oxygen, I have 2 oxygens on the reactants side. And I have here 1 oxygen atom on the product side. So here I have a problem. The numbers are not balanced, so we will add number 2 before magnesium oxide and adjust totals. For here, I have 2 magnesium atoms in the product and 2 oxygen atoms in the product. So I have here 2 magnesium atoms in the product and 2 oxygen atoms in the products. But here I have a shortage and a problem in the reactants, because here I have 1 magnesium atom in the reactants and 2 magnesium atom in the product, and this is not correct. So we will have here, we will put 2 magnesium, 2 before the magnesium atom, and adjust totals again. 2. So we have here both sides are equal numbers, have equal numbers of atoms. I have here 2 magnesium atoms produces 2 magnesium atoms in the product, and 2 oxygen atoms produces 2 magnesium atoms in the product. So this equation now is balanced. Here's a exercise. Here's an exercise on some equations, and try to balance them using the same method. I have here Na plus Cl2 produces NaCl. CH4 plus O2 produces CO2 and H2O. Li plus HNO3 produces LiNO3 plus H2. And here Al plus O2 plus equals Al2O3. I have here 1 sodium atom produces 1 sodium atom, and 2 chlorine atom produces 1 chlorine atom. So this equation is unbalanced, and also the second and the third and the fourth. Here are the answers. To balance this equation, we will put 2 before Na. Here we will put 2 before oxygen, and these are the answers. Try to solve them by yourselves, and here you have the answers to make sure that your answers are correct. The second part is the laws of chemical combination. I have 2 laws of chemical combination. Number 1, it's called the law of mass or matter conservation, and number 2, the law of constant ratios. First of all, let's talk about the law of mass or matter conservation. According to the law of conservation of matter, it states that the matter is neither created nor destroyed, but it can be changed from one form to another. And this is called the conservation law of matter. But by applying these and by applying this law to the chemical reactions, we defined it as the sum of reactants masses in any chemical reaction equals the sum of the product masses. It means that the mass of the reactants, the summation of the mass of the reactants equals the summation of the product's masses. For example, knowing that the atomic mass of magnesium equals 24 grams and the atomic mass of oxygen equals 16 grams, I have here a balanced chemical equation. 2Mg plus O2 equals 2MgO. 2 atoms of magnesium or 2 molecules of magnesium plus 2 atoms of oxygen or 1 molecule of oxygen produces 2 molecules of magnesium oxide. How can we calculate the mass of this equation? By here multiplying this 2 number of molecules and the atomic mass of the element. The magnesium here is 24 grams. So by multiplying 2 times 24, it equals 48 grams. And here 2 times 16, because the atomic mass of the oxygen equals 16. So 2 times 16 equals 32 grams. Here 48 plus 32 equals 80 grams. And 2 here, magnesium and oxygen, to calculate the mass of magnesium and oxygen, we will plus or we will add the atomic mass of the magnesium, 24, plus the atomic mass of the oxygen, which is 16, and it will equal 40, and we will multiply them in the number of the molecules. So I have here 2 times 40. We will find out that the sum of masses here of the reactants equal 80 gram, and here the sum of the products equal 80 gram. So here this equation achieve the law of conservation of mass. By the way, the law of conservation of matter or the mass cannot be applied if the equation is not balanced. So before achieving the law of conservation of mass, we must be sure that the equation is balanced. Number 2, the law of constant ratios. And the law of constant ratios states that the chemical compound is formed from the combination of its elements by constant mass ratios. By applying the law of constant ratios on the reaction between magnesium and oxygen, during the reaction between magnesium and oxygen to form magnesium oxide several times by different weight masses, we notice the following results. Here, if I have 2 magnesium atoms and 2 atoms of oxygen, the total mass of magnesium is 48 grams, and the total mass of the oxygen molecule or the 2 atoms of oxygen is 32 grams. It produces 80 grams of magnesium oxide. By simplifying these 2 numbers, 48 and 32, we will find out that the ratio of magnesium to oxygen to form a molecule of magnesium oxide is 3:2. If I have different amount of masses or different formula of this reaction, by reaction of magnesium and atom, 1 atom of magnesium with 1 atom of oxygen to form 1 molecule of magnesium oxide. Let's try here. I have 24 grams of magnesium and 16 grams of oxygen. It produces 40 grams of magnesium oxide. By simplifying these 2 numbers, 24 divided by 8, it produces 2, and 16 divided by 8, it produces also 2. So here, the ratio of magnesium to oxygen is 3:2. From this example, we conclude that magnesium oxide compound is always formed from the combination between magnesium and oxygen elements respectively by constant weight ratio, 3:2. However, the masses of the elements involved in the reaction changed according to the law of constant ratio. So, however, the masses of the elements involved in the reaction, the magnesium oxide is always formed from the combination between magnesium and oxygen elements respectively by constant weight ratios, which is 3:2. So the law of constant ratios states that the chemical compound is formed from the combination of its elements by constant weight ratio. If the ratio, notice that an important note, if the ratio between the masses of elements that enter the chemical reaction differs from the fixed ratio which these elements react with to form a certain compound, so the increase in the mass of each of them remains without reaction. If I here, for example, I have here 50 grams of magnesium, it will produce the same ratio, but 2 grams of magnesium will stay without reaction. So the increase in the mass of each of them remains without any reaction. Again, the increase in the mass of each of them will remain without reaction. This is the first part of the lesson, and it talks about the laws of the chemical reaction. And the second part, we will talk about the types of chemical reactions and the importance of the chemical reaction. So, see you next time.